Well, hey, class. Good morning and welcome back. Actually, it's probably good afternoon as we're watching this, but if you're watching it in the morning, good morning. Anyway, we are starting chapter 2 today. Chapter 2 is one of my favorite chapters because it kind of hits the area of math that I really love, and that is statistics and dealing with data. So you're going to see a lot of things written up here on the top, and it'll be good to make sure you note some of this in your notes so that as you're working with your calculator quite a bit today, you know how to find these values rather quickly. So as it says up there, lesson 2.1 and 2.2, we're actually for 2.1 going to do the vast majority of these notes, and then we'll finish up in another video the 2.2 part. So there's one section that we spend a little extra time on knowing how to do. So anyway, today's lesson will focus on measures of central tendency and box plots. So how do we, in essence, start to analyze and visualize a bunch of data that we're given? Okay. So what I actually have done here is I've started and I've put an example set of data, a pretty small set of data that I'm going to use for a bunch of definitions here. So the question is, how do I go about putting this in my calculator and start to analyze certain values? Okay? So what I'm going to show you here is how do I put this data in my calculator? So it says here, how to enter data in your calculator. You'll hit this key that's called stat and the number 1. So right on your calculator, kind of right in the middle, you can see I'm circling it here. I'm going to hit the stat key. And then I go up here and I just want to hit number 1, or I can just hit enter because I'm going to edit. Now you can see I actually have some data in my calculator. Okay? And so I'm going to want to get rid of it. So I'm going to talk about a few things here depending on your calculator. Most of your calculators, if they're new, if I go up and put my cursor right on L1, okay, I have a whole bunch of numbers. I want to clear these out. So you have this clear button and you have a delete button. Clear is the button you want to use in statistics the most. It clears it out, it doesn't remove it. So when I hit clear and then I hit enter, all the data disappears, it takes it out. However, if you accidentally hit delete, notice how list 2 disappears altogether. In fact, if I accidentally go, oh my goodness, Mr. Varts, you've just messed everything up. You've deleted everything. How in the world do I get all this stuff back? Well, if you hit your stat key and you hit number 5, set up editor and hit enter, what that does is if I go back to stat and number 1, it actually puts all those lists back in order. So if you ever get into trouble, stat, okay, number 5. That's a way you can set up the editor, okay, and get your lists in order so that you can use like list 1, list 2, list 3, and so forth. I'm going to go to stat and 1 to start. So now I'm going to type these data points in. I just simply start typing 20, enter 22, enter 25, 28, 30, 32, 37. Looks like I have a couple of those, thank goodness, and then 41. We'll see why in just a second. Now, when I get my data in, one of the things I do is I double check. Because if you enter in any of these data points wrong, it messes up the entire problem. That just stinks. So 20, 22, 25, 28, 30, 32, 37, 37, 41. So I just kind of double check them just to make sure that they are correct. All right, so measures of central tendency. So there's 2 of them that, well, there's 3 listed here, and they're the 3 M's. But I'll be honest with you, the last one is really not a measurement of center. It is basically, it helps you determine shape. But I'll talk about that at a later time. So when we talk about mean, there's this symbol called X bar. I'm going to show you where you find that on your calculator. We call it X, and it's got a little bar on top of it. It represents the mean, and the mean is simply the average. Okay. While the median, okay, we always think of the median as the middle, kind of like the median in the road. So what the median does is, here's the median. I'm going to abbreviate it, and it's usually abbreviated MED. 50% of the data is below the value, and 50% of the data is above the value. So it divides it into two equal parts. So mode, you guys probably remember this, MO, remember that? It's the most or most repeated value. Okay. So in our case, I'm actually just going to go right away and look here and say, 37 was the only one that was repeated, so 37 is our mode. Okay. Now, if all the numbers are different, you have no mode. Okay. However, you could have multiple modes. Okay. You could have two modes, which sometimes we refer to as bimodal. Okay. Now, if I want to find these values right here, two ways I can do it. Okay. For the mean, I could add them up in my calculator and divide by the number of terms. That's not terrible for this set of data, but when we have 30, 40, 50 data points, that takes a lot of work. So we're going to show you on your calculator how you get it. And you can see it right here. To get X bar, where you hit stat, the right arrow, and number 1. So I'm going to show you how we do that. So I'm going to hit the stat key. So here's my right arrow. I'm going under this menu called Calculate. And I want to select this number 1, which stands for one variable statistics. Now, depending on your calculator, what mode it's in, lots of times if you got the newer ones, you just change that to list 1. If you have an old calculator, you can simply hit enter and it defaults to list 1. Okay? So, but if you have this menu, you change that to list 1 to get list 1, second 1. Okay, you can see there in blue, list 1, second 2 is list 2, second 3 is list 3. Go ahead and hit calculate, takes a minute, and look at this. We get a whole bunch of things, and this menu is going to help us a lot. So right there, right at the top, there's our X bar. So our average on this one ends up being, we can say X bar equals 30.2 repeating. So now, you might be saying, well, Mr. Bartz, we got all these other weird symbols, but I don't see anything that says MED. See this little down arrow right here? Well, let's hit our down arrow all the way to the end, and you can see all of a sudden MED pops up. The median, in our case, happens to be equal to 30. Now, when you have a small set of data, if I look at this, here's 30. Notice how I have 1, 2, 3, 4 data points to the left, and 1, 2, 3, 4 data points to the right. Divides it into two equal pieces. Sometimes students, what they'll do is they'll start on this end and this end, and they will count. Unfortunately, I can't have two little cursors, but you kind of move yourself back, and you'll go like 1 and here, and then here and here. I don't know if that's making sense. Here and here, here and here. That's left, that's the median. Sometimes it's in between two, and if it's in between two, you take the average of it. All right, so now we've talked about measures of center. The next couple definitions will deal with measures of spread, meaning if we look at what is our data, how far or how much distance is there between data points. So one measurement is called standard deviation. We use this one quite a bit in statistics. This is the average distance a data point is away from the average. So it's a comparison to the mean. Now what's cool is we don't actually calculate it by hand. We use technology to help us. And it's this symbol on the calc. So on the calc, you'll look for S of X. And notice how here in this 5-number summary, it's right here. S of X equals, so in our case, 7.2, I might go 0.7. Usually I might go up 3 data points or 3 decimal points. So now another measurement of spread, okay, is range. Okay? The range is simply taking the maximum value minus the minimum value. It's a single value. We don't say it goes from the minimum value to the largest. We actually give it a single value. So in this case, our maximum value, our biggest value here was 41. In fact, if you look at how we have the median, your calculator will actually give them to you here. We can easily see it's 41 was the max, and we can easily see right here that 20 was the min. So I can actually get it by simply going 41 minus 20, or the range is 21. Okay. Now, the one thing that we just talked about here was our 5-number summary. So our 5-number summary is these particular 5 numbers. And what the 5-number summary does is it divides the data into 4 equal pieces. Okay? And it will show up a little bit better, and I'll make the connection a little bit better when I talk about the box plot. Okay? So before I finish or go to the box plot and such, you'll have the minimum and maximum, median. Remember that median? If you think about the median, it's the 50th percentile. 50% of the scores are above and below it. Q1, think of the letter Q as quartile. Okay? So this is at 1 quarter. 1 quarter is like 25%. 2 quarters is the median. 3 quarters, okay, is 75%. 100%, 0%. So you can see it divides everything into quarters. Okay? So another measurement of spread, which can be very important, is what we call the interquartile range. It gives us the distance of the middle 50% of scores. So in our case, what's kind of nice to see is, Q3 was 37. Q1, look at that, 23.5. So if I subtract those two, I get 13.5 for my interquartile range. Now, if you had to find it by hand, it gets a little more challenging. So what happens here is, here's the 50th percentile. What you'd actually do is find the middle right here, score, for Q1. So what you would do is you'd average those two. 22 plus 25 is 47. Half of 47. That's where the 23.5 was coming from. If I look here I have 4 data points. I find the median here. Well, it's between 37 and 37. So that's why Q3 was 37. That's how you would do it by hand. But I tell you, I'll use that 5-number summary all the time. Okay? When doing my box plot, or I should say, when finding Q1 and Q3 in interquartile range. Got a little ahead of myself there. Box plots, box and whisker plots. So this is a graph of the 5-number summary. So what I'm going to do here is I'm going to start here by drawing a number line. My number line here, if I look at my data, okay, I have a low of 20 and a high of 41. So what I might do here is just start at 15 and count by 5s and go up to go up to 45. So I kind of get a nice little picture of the data. So lots of times, what I will do is look at where the min and max are and scale my x-axis. So a box and whisker plot. You might remember box plots kind of looking something like this. Okay? That's what, in essence, we're going to draw here. But how do we get these values? Well, the end is the min, or the left end. The right end is the max. The middle line in the box is the median. The one side of the box is Q1, and the other side of the box is Q3. So many times when I do my box plots, I like to start with the box. So I start with this Q1 and Q3 value. So Q1 was 23 and a half. So I'm just going to kind of estimate it the best I can, and I'm going to draw a side of a box. Q3 was at 37. Draw a little side of a box. So now I draw the whole box. Now the median is at 30. So right here at 30, boop, put a line. Now just know that the median doesn't always divide the box in half. This one didn't quite. It was close, but not quite in half. So now to do the whiskers, I draw this whisker down to 20. Then I draw this whisker all the way up to 41. And I got my box plot. simply a graph of the 5-number summary. All right, the last thing we're going to talk about is how we describe the shape of our distribution. So to kind of keep it basic and pretty simple, we'll either talk about the data being symmetric or we'll talk about it being skewed. Okay? So when we talk about it being symmetric, basically the left side and right side from the median are about the same distance. So what I'm meaning here is, if here's my median right here, this distance here is about the same as this. Doesn't have to be exact, but when they're close to being the same. So we say it's symmetric. So like this one up to here, 30 going to 20 is 10, 30 going to 41 is 11. That's pretty darn close. So I would say that even this box plot here is, and sometimes I'll use the word roughly, just to note that it wasn't perfect, roughly symmetric. Okay? All right, now skewed data is where one side, whoops, didn't take my new color. So when we talk about it skewed, I want you to think of the word, and this is kind of the interesting part of it, is the word skewed actually means tail. Okay? It's where one side is, whoops, I forgot the E inside, is longer than the other side. And again, I'm just going to put in parentheses here, from the median. Okay. So to finish this up, notice how here's my median, and if I look here, the right side is much longer than the left side. So what we like to do is we actually describe the skewness. We would say skewed to the right. Here's the median here. Notice how the left side is much longer than the right side, so we would say skewed left. So lots of times when we describe skewness, we don't only say that it's skewed, but we like to say which direction it is skewed in. All right, let's take a look at just a couple quick examples, okay? And then we'll be done with the notes. All right, so in this example here, it says, here are the scores on the semester assignments for 2 students. One of the things that I'm going to do here, just to make this a little bit better, is I'm going to cross out Connie's score right there, that first score, and replace it with 72. Trust me, it'll make things a little bit easier. And then I have Oscar's score. So what I'm going to do is I'm going to do Connie's scores with you, okay? And then I'll pause it and have you try Oscar's and then see if we get the same values. So I'm going to go stat. I'm going to go edit, and I want to enter in Connie's score. So again, what I like to do is highlight list 1, hit clear, and then enter. So as I do that, what's nice is that all disappears, and so now I can just start typing in the data points. 72, 86, and what's nice is they don't have to be in order. They calculate, whoops. So let's see here, because sometimes it doesn't like to take my enter there. 82, 84, let's see, 85, 84, and 85. All right, I have my 2, 4, 6, 7 assignment scores. So now, I'm going to go right away to stat. I'm going to use the right arrow, one variable statistics. It's already set on list 1, and I'm going to calculate them out. So remember, mean is the X bar value. So I just look at my calculator, 82.571. My mode, unfortunately, mode is not done on the calculator. So if I look here, I have two 84s and two 85s. So I have two of them, 84 and 85. And that can happen. Your median is your middle. So scroll down. Don't look at the data and just say, oh, it's this one right here, because the data is not in order. To do it like I showed by hand, it has to be listed in order. This is where the calculator helps a lot. 84. Range, remember, is max minus min. So my range in this case is 86 minus 72, or it's a range of 14. My standard deviation, that's the symbol S of x. So I look at my calculator, 4.826 if I round. Okay, so that's like the average distance from the median. It says give the 5-number summary. So my 5-number summary, 72, 82. Median's kind of a repeat, 84, 85, and 86. Nice. All right, take a second and now do Oscar's scores. Okay, pause the video if you'd like and try Oscar's. All right, if you've come from the unpause or you just kept on playing, I'm going to do Oscar's here just to show you stat. What I'm actually going to do, just to be a little different, is I'm going to put Oscar's scores in list 2, okay, just to show you that you can actually do more than one list in your calculator at a time. Okay, so I got all my data in there. Of course, it's always good. I'm just kind of checking it here. So now I'm going to go stat, calculate, one variable statistics, but this is where I have to be careful. I have to do it on list 2. I hit calculate, and now I can start writing these values. 84. Let's see, was there a repeat? Looks like 76 is the mode. My median, if I scroll down to the bottom, was 84. My range, my max was 96. My min was 72. Looks like I have a range of 24. Standard deviation, remember, is that symbol S of x, 9.592 if I round 3 decimal places. 5-number summary there. So again, is 72, 76, 84, 94, 96. Okay. All right, so the last part here I'm going to do is C and D. It says construct side-by-side box and whisker plots for the students. And then D, I'm going to describe each graph as symmetric or skewed. Okay, so I'm going to first start with a number line here. So if I look at my number line and I'm going to put them together, my low was 72 for both data. This one only went to 86, but this went to 96. So I might start here at 70 and make sure I go up to 100. So 70, 75, 80, 85, 90, 95, 100. So I got my number line. So now I'm going to do Connie. I'll just use a C here. So let's see here. I like to start with the box because it's pretty small, 82 to 85. So I have a line here at 82, a line here at 85. The box is kind of small. And the median was at 84. Now the min goes to 72. Max was only 86, so really short there. So in fact, I'm going to describe this. Notice how the left side is much longer than the right side. So I know that this one here is skewed left. All right, let's take a look at Oscar's scores. So as I look at Oscar's, 94 and 76. Wow, here's 76 and 94. So So I got a really big box. My median is at 84, kind of at the same spot. So let's see, the min goes down to 72, and the max goes to 96. So now when I think about this, okay, median was 84 to 96, that's 12. 84 to 72 is also 12, so I'm going to say symmetric. Okay. So now we can kind of start to get a picture of Oscar and Connie's scores compared to them. Looks like Connie's a little more consistent, but tends to get some low scores. Oliver is all over the board, sometimes gets really good scores, sometimes gets really low scores. Now this part E is all about tomorrow. I know I didn't talk about outliers. We'll wait for that for tomorrow. All right, last page. Okay, I want to, oh, shoot, I didn't clear this off. So let me clear it out. I thought it was clear. So some of your homework today will ask you to invent data set that fits this criteria. So this really makes us really think about, okay, what does the mean actually represent, the median and the mode, okay? So when I do problems like this, so I'm just gonna read A. It says 5 values, the mean is 15, the median is 13, and there's no mode. Wow. Since mean is average, okay, and what I like to do here is I'm just going to take this and kind of go down here. It says to invent 5 values. So what I do is I create 5 kind of blanks that I'm going to fill in. Now when I fill them in, I need to make sure I write them from the lowest to the highest value. Because if I don't, I'm going to mess up the median. Okay? So mean is average, median is the middle, mode is if it repeats. So right away here it says no mode. So all the numbers must be different. Okay? The median means the middle has to be 13. Well, since I have 5, if I look at the third number, I can write 13 right here. I have 2 numbers on the left side, 2 numbers on the right side. So I know my median is right. Now, 5 values and the mean is 15. So how I make sure the mean is set correctly, if I have 5 numbers and they all were 15, they would average to 15. So if I multiply those two together, just to show you, 5 numbers times an average of 15 means all the data points must add up to 75. So it must add up to 75. So now, this is where you and I totally could have different answers, and we still could be right. What you just need to make sure is that the numbers are different. Okay? So, some students will just say, well, you know what, over here I'm going to write, simply I'm just going to go 12 and 10. So right now I kind of think to myself, I have 10 plus 12 is 22 plus 13 is 35. So I still need 40. So these 2 points have to add up to 40. So I might go like 18 and 22. Notice how they're in order, okay, from lowest to highest. Make sure you do that because if you don't, you mess up the median. Okay? All right, let me show you one more example, one that's a little bit harder. So now I have 6 values. The mean is 24. So lots of times I start by going 6 times 24. So quick, 6 times 24 I think is 144. Look at that. So I know my data points have to add up to 144. So 1, 2, 3, 4, 5, 6. Okay? The median is 25. Okay? So that means the middle. Well, when you have an even number, this is where it gets tricky. The median isn't one of them. It's actually in between. So the median actually has to be the average between these two values. Now, lots of times I'll just go ahead and write 25 and 25. But I'm going to hold off here because the mode is 28, meaning the most repeated number is 28. So if I put 25 and 25 here, I only have 2 spots left for 28. Well, the mode could be 28 and 25. So that's where I got to be a little bit careful. So for my median here, to get it to be 25, what I might do is say, all right, what's 1 less than 25? 24. And what's 1 more than 25? 26. Because if I add these two numbers together, they give me 50. 50 divided by 2 is 25, so the median is 25. This allows me then to say, all right, these two numbers are 28. So now I'm going to see how much I already have. So if I go 24 plus 26 plus 28 plus 28, I have 106. So 144 minus 100, helps if I put the 106, leaves me 38. So these last two numbers have to add to 38, but they can't be the same. So I'm thinking maybe I can go 20 and 18, and I have my answer. Sorry, that looks like a decimal there. That should just be 18 as such. All right, that takes care of the video for 2.1. Go ahead and work on worksheet 2.1 and check the video key if you have any questions. All right, have a great day, everybody. So I'm just trying to get to stop the video.